Okay, you can consider this question as a continuation or part 2 of the video on independent and dependent events and probabilities and conditional probability. So watch part 1, it would be better. But this one is kind of independent of watching part 1. It's better, just I suggest you watch part 1 of this before you watch this part. So we have again two events A and B, and you are given the probability of A 0.15 or 15%, probability of B 0.32 or 32%, and you have the probability of A given B is 0.18 or 18%. And then you have three questions. Are the two events independent? Then the second question is, what's the probability of A and B? This one here, the probability of A and B. And the third one is, find the conditional probability of B given A. This one here, probability of B given A. So let us do them one by one. The first one is, are A and B independent? In fact, you can answer this very quickly. You can notice that the probability of A given B is equal to its given. It's 0.18. You can see it here. And what's the probability of A? The probability of A is, let me instead write the probability of A like this. The probability of A is 0.15. Notice that these two numbers are not equal. So what you can conclude from this is that if B happens, if B occurs, then it changes the probability of A. The probability of A originally is 15%, yes? And when B is given, probability of A increases. It becomes 0.18. So immediately I can conclude from this, this implies that A and B are not independent. They cannot be independent. If you watch part 1, you will see that if they were independent, then the probability of A given B and the probability of A remain the same because B doesn't affect A when they are independent. But if the two probabilities are different, then they are not independent. Make sure you understand this. We will come back to it in the second or third part. So the second part, what's the probability of A and B? This one, probability of A and B. So we know the rule, probability of A and B, you know, okay, let me do it this way. So let me teach you everything. So if they are independent, then it is probability of A times probability of B. You don't have to think about it. It's just once you know that they are independent, then you just multiply the probabilities. But if they are dependent or not independent, then you can have one of two, because it doesn't matter which one you use. You can say this is the probability of A times the probability of B given that A happened, or the probability of B times the probability of A given that B happened. And in our situation, if you remember from the previous one, they are not independent. We have shown that they are not independent. So we know that we cannot use this rule. So not this one. And so we either use this one or this one. But we just look at the given. Which one is the one that we can use? We can use actually this one here. Let me choose a different color. We can use this one here because probability of A given B is given to you. You have it. And probability of B, of course, is given. So these two are given. So you can use this formula and say this is equal. Probability of B is 0.32 times probability of A given B is 0.18. And if you multiply these two on your calculator, you'll get 0 0.0576. Okay, so keep this number in mind. This is the probability of A and B. We noticed that they are not independent from the first part, and so we looked at what we're given and we found that this is the rule to be used. The other rule, the one above it, you can also use it, but unfortunately you are not given this one. We now can compute all of them, but you just look at the given. The given makes it easier to choose which rule to use. So that's why we don't use this rule for here, because what we were given at the beginning was probability of A given B, and it is the one that is in this rule. Any of these two rules will work, depending on what you're given. Let's go to the next part. It says, find the conditional probability of B given A. So remember, the probability of B given A is equal to, if you want to go back just a second and look at the rule here, let me choose this color so you can see it as part of this rule. Probability of B given A, if you multiply it by the probability of A, you get the probability of A and B. So probability, you can say, of A and B, from this you can choose the first rule when they are dependent. It's probability of A times probability of B given A. And so this would imply, this rule here is going to imply that probability of B given A is just divided by the probability of A. Probability of A and B divided by the probability of A. And this is a nice rule to remember. It was also included in part 1, and I made you remember it easier by looking, when you have conditional probability, the one that comes after the vertical bar is the probability that you have down. Okay? And the one above is always the probability of A and B. So I can say here, probability of B given A is the probability of A and B divided by the probability of A. And this would give you probability of A and B. Remember, we have calculated it here. That was the purpose of the second part of this question. Probability of A and B is 0.0576. So this will be 0.0576 divided by probability of A is 0.15. And if you do this on your calculator, you will get 0.384 exactly. Notice, we have solved the question already, but I just want you to learn a little bit more than just solving the question. Notice that this number here is not the same as 0.32, which is the probability of B. So this means that probability of B given A is not the same as probability of B. You can say, therefore, let's write it, probability of B given A is different from the probability of B, and immediately from this you can say that therefore A and B are not independent. Okay, and I like to remind you of things all the time so that videos can be watched and you learn from them without having to always watch something else. So when you see that something like this happens, you try to remind yourself, you say, so when are they independent? In this case, they are not independent. But if A and B are independent, A and B are independent, so you can say if A and B are independent, then the probability of B given A must be the same as the probability of B. And you also remember the rule. And also, if they are independent, if you want to know everything, also probability of A given B must be the same as the probability of A. And also, there is the first rule that we learned about independence. If they are independent, then the probability of A and B can be computed as the probability of A times the probability of B. Everything here depends on the given. The fastest way to do it is to look at the given and then decide which one to use. And this would end this question. Just remember that we already finished the solution here. So this was the end of the solution for this part 3. I just talked more in order to remind you of ideas so that you don't get confused. I hope that by repetition of ideas, then you get to understand it and not get confused with these things. And I will end the video here.